All right, I think I am going to start.
Yeah.
So, yeah, I'm not totally sure how long this talk's going to go because I haven't given it before. So we're going to find out, and hopefully I have enough time or I don't end like super duper early. From fuzz to function, that's true. If we end early, then we got to go to a bar early, right? So, AI for next gen apps. There's a few things I need to get out of the way first. That's me. I think this is my third year in a row speaking here, which is awesome. Every year there's like a few more open source projects on here, but basically, if you know me, I mostly do open source stuff, and these are the open source projects that I'm largely responsible for. That one up there in the top left corner, I just launched like, I don't know, an hour ago or something like that. Yeah, awesome. So I'll talk about it a little bit today. It's technically not really open source, but you can go read about it. All right, AI. This is what we actually have to get out of our head. So global destruction. I feel like every AI talk, you got to like start here because this is sort of what everybody's like tangentially worried about. And we all think either we're going to end the world or this is just a way to write your code faster. And this is a ridiculous dichotomy between the two things. But that's basically where we are. It's like we're all really excited that our code's getting written faster. And yet we're all slightly suspicious about the whole global destruction thing. So really what you care about is AI going to replace your job? I'm just going to get this over with because it has nothing to do with my talk. Most of you, according to Stack Overflow, say no. AI is not going to replace my job. So should I at least be using it to write my code? Yes. You should absolutely use it to write your code. Is everybody using it to write your code? What's your favorite? Cursor? Yeah? Who uses something else? What do we got?
Grok.
Oh, Grok, okay. What else? Okay, Copilot, yeah. Yeah, I'm really partial to Cursor right now with their agent mode. It's killer. So yeah, you should use it to write your code. Will AI replace my job? Yes, absolutely. You didn't want me to say that, but it will 100% replace your job. I don't know when, but it's just the writing's on the wall. It's going to happen. And so you better stay up with it. I'm not going to like, last year I spent my whole time trying to convince people of this truth. And now it's just so inevitable that I'm just going to say, will AI destroy the world? No, it's not going to destroy the world.
Maybe.
Well, maybe. Actually, yeah. It's not, maybe. But do humans have value anymore? Yeah, of course we still have value. Okay?
Maybe.
No, we're not going to talk about this, but they're all things for us to be thinking about. We just want to know how to use this to help this happen faster. So creating AI first apps. Right now you're seeing a lot of this on the internet, which is like your traditional deterministic app with a little button on it that's like AI. And then you click that and a little prompt comes up and you don't know what to type into it. And then you have a bad experience. That is almost exclusively the type of AI that we're actually seeing make it into the world, apart from the chat GPT-like apps where you are left in a complete open world. But I don't want to talk about this because I don't actually think that this is very important. I think this is a very short-term phase where you got a bunch of companies that are like, oh my gosh, there's so much hype here. I need to do something, but I don't want to change my business. So maybe we could just add a little AI on top of my business. I'm not that interested in making those apps, and I don't think you should be either. So what is AI first? This is my definition, nobody else's, but I believe it's an app where the primary input mechanism is non-deterministic. So in other words, ChatGPT is a good example of that. But anytime that you're pushing a button, you're clicking something, and you have this deterministic input going in, I'm going to put that in a category of older apps, and I'm going to say that there's a new type of app that's going to emerge. We're actually really familiar with this. If you think about it, Siri came out like ages ago. The problem is it's always been crap. All of them have been bad, right? Which is why that ChatGPT moment was so crazy for everybody. It's like we all went through this incredible moment where it was like, whoa, the assisting thing can actually be good? We didn't know that. And it's still amazing that Siri's still crap. In fact, they're all still bad. And so there is a little bit of a sense of like, what is going on? I thought AI was going to change the world, but the only place where this is actually useful is writing my code or in my chat app. So I just want to imagine for a minute a whole new world here and some types of apps that you could actually build today. None of these exist that I know of, although there's like constantly new ones that people are trying. But they're just some ideas, some things for you to ruminate on. How about something like off-hour triage for medical offices? And don't think about all the liability stuff for a second. Like I have 3 little boys, and they always get sick or hurt on the weekend when the place is closed, right? And then you end up calling on the phone to some crazy, like I don't even know what the system is, but it's obviously not somebody even in the state. And then they like put me on hold for a long time, and then they call the doctor. I don't know. It's really dumb. But imagine if you could just have a triage assistant that was all done by AI, that was very, very good at understanding that I am listening to problems of like real human beings whose kids are hurt, and then trying to determine what to do and getting a hold of people immediately if that's what was necessary. Like you could write that app. You could write that app today and make money. How about something like a personal stylist, right? Where you get to have an app and then like take a picture of yourself every morning and just be like, is this good? Is this match my brand? Is this, you know, do I look right to go to work today? I have an interview. What should I put on? Somebody that actually knows you, knows what you looked like for the last year, and then can continue to give you recommendations. You could write that app. How about a curriculum, like a homeschool curriculum that comes with the teacher? That sounds a little creepy, but I don't think it actually is. Imagine if there was a great homeschool-like curriculum, and instead of the parent being the bottleneck for the kid learning, they actually had something like a teacher bottled up in that curriculum that they could ask questions. They knew the strengths and weaknesses of the student as they went along. They were able to suggest things about, hey, you seem like you're having a hard time learning it this way. Let's try learning it this way, right? That would be incredible. You guys could build that app. Contract analysis, right? Imagine just getting a bunch of contracts, learning about those contracts for your business and trying to determine like, is this a good contract? Is this a bad contract, right? And just being able to have some sort of even if it was just a classifier that was like, yes, good contract, no bad contract, okay? Like, is it a hot dog? Same thing for contracts. You could build that app. You could probably build that app. That's an easy one. You could build that one like real fast. Third-party insurance advisor. Imagine if there was insurance advice that didn't come from an insurance company. It came from a third party, and all that it was like consumer reports for insurance. But the job of this AI assistant was not to be like, here's a magazine like NerdWallet that tells you some of the best things. It was to talk to you about your problems, learn about what risks you are exposed to, and then give you the best recommendation from any of the providers. Like, you can make that app. These are just some ideas that I came up with. And they're all perfect for this non-deterministic input, where you want the fuzzy input of a human being to turn into something deterministic at the end. That's the key. So I think the main reason that these things don't exist yet is that AI is actually not very easy. And I don't mean for the users. For users, it's pretty easy. You just talk to it, right? But for us developers, it's actually pretty stinking hard to work with. And I want to go into that in a lot of detail today because I got lots of, wounds to prove it. And basically, just have a moment here to talk about war stories and what kinds of things can help you on your journey as you look into this. So I've got 4 main problems that I want to list. First is that there's no standard approach. When you're deciding you're going to build one of these apps, there is no blog article that you can read that's actually going to be helpful to you. I guarantee it. And the reason is nobody knows. Nobody knows the right answers yet. We don't know. I don't know the right answers. I've got some ideas that I've accumulated over time, but this space is so fresh that you actually have an opportunity to make an impact, but that means you need to do your own pathfinding. You need to figure out your own way through these things. So there's no standard approach. Also, there is a tremendous lack of personal intuition on your part. We kind of understand as developers, we get a sense and intuition over time for how to pathfind to the right answer when we're writing code. When you're dealing with AI, you just don't know. And if you think you do, you probably don't. it is non-intuitive what kinds of prompts are going to lead to good results. And you see that people share these things on all the time online. Like, here's my system prompt that I use that makes everything great. And that might be true for one model, but not for the next model. And there's no clear standards around this stuff yet. Also, there is very poor tooling in the ecosystem. There are tools, they pop up all the time, but in general, the tooling is poor. The tooling might be vendor locked. There's a lot of challenges around introspection of what's going on, developer tools, testing, all that kind of stuff. So it's not good tooling. And finally, the models are either really stupid or they are stupid expensive, super expensive. So like, we were just talking about Cursor earlier today, and like it's like $20 a month. I don't know. Does anybody here like work for Cursor? Okay. I don't know this. I guarantee they are hemorrhaging money. Guarantee it. Because like when you actually build an app with AI, you'll see it is really expensive to get good results, unless you do a lot of engineering on your part. So a little bit about no standard approach here. First of all, like what UI are you even going to present to your users, right? Is this going to be another like in-app chat interface? Are you drawing pictures? Like what is the way that you're going to communicate? There's no path paved there. Can you just rely on kind of one-shotting to an LLM and to try to get a good answer back or not? How do you engineer the solution to this? Do I need to build an agent? What even the hell is an agent, right? I don't know, right? You've got to figure that out. Also, do I get structured data out? And if I do, how do I get structured data out of this thing? In other words, if I want JSON back out, how do I get JSON? There's a lot of different ways to do it. Some of them are good. Some of them suck. So take this. Okay, we got Fibonacci here. I've got 3 versions of Fibonacci. All right, I want you to look at 3 of them, and I'm just going to ask you which one you like the best.
Not that one.
Here's number 1. Here's number 2. Here's number 3. Who votes? There's not a right or wrong answer.
3.
I think I'm number 2.
2, yeah.
Okay. All right. We all have a sense of intuition, though, right? Like the short code looks good, but it's a little obtuse. The long code is really dumb. So like we have a sense of intuition. In AI, here are 3 prompts for a cookie dough recipe creator. All right. This one's written here like Markdown. This one is written as XML. And this is just plain text. What's your intuition? Which one's going to perform the best? Number 1, 2, 3. A lot of number 1s. Turns out it totally depends. There's no right answer. If you're dealing with Claude, this is actually usually pretty good. If you're dealing with OpenAI, this is usually better. And for a lot of the other ones, this is better. So it just depends. But your intuition about it will probably be wrong. And then what will happen is you'll go really far down the path of engineering a solution for that before you realize you screwed up and you got to back all the way back up. And this is part of what I'm saying is like we don't have a lot of this muscle memory built up yet. Poor existing tooling. There's a lot of new things you get exposed to when you're really dealing with building an AI app. A lot of things that even having done programming for many, many years, I hadn't spent a lot of time with. So real-time stream parsers, you need to evaluate and test, not just test. Like how do you test something coming out of an LLM that's deterministic or that's probabilistic and not deterministic? Well, you need an LLM to test it. You need to ask an LLM, was that good or was that not good? We call those evals. Chaining, how do I chain these models together to get better stuff? State isolation. So in order to reproduce a bug, you have to reproduce a conversation. That sucks. Somebody can tell you, hey, I ran into this bug. I asked it to do this for me and it didn't do it. And you will never be able to reproduce it unless there's some way you can freeze that person's state at that moment and pull it into your dev environment. There's no tools for that. How about like model routing from one model to another? Okay, I start maybe on a really smart router and I go to a dumb router, something like that. Multiplexers, that's a whole other thing. We'll talk about that later. Context injection. So how do I get the context into my prompt, right? Because these things are actually statements. All of these are basically tools that don't really exist, or they only partially exist. So models are stupid. I just ran this yesterday. So I asked it to sort by the biggest number, and it just got it catastrophically wrong here. And then I got it catastrophically right. This is the exact same ChatGPT, just that one is 16 times more expensive than the other. So you can either have really affordable AI that sucks, or you can have really expensive AI that's much better. So these are a lot of the problems. So let me spend some time waxing poetic about some of the solutions that we've found in some of the stuff that we're building. First of all, there are some patterns starting to emerge. Reminds me a little bit of the early days of the web. Well, not the early days. Back then, everything was crazy. But like, 2012, 2011, when we all started realizing, okay, JavaScript still has some more legs to it. And we were basically missing the tools to make it right. And then they started popping out here and there. And we started arriving at patterns. We finally arrived now at a place where I'd say the patterns are pretty much set, right? React and Vue and Svelte and Solid, they're all basically the same thing. They all roughly look the same way. You can pick one up from the other in a matter of days, maybe even hours. That's not yet the case in AI, but it's starting to get that way. So first of all, you probably want to use a router. And a router is basically a way for the query to get to where the answer is going to be. So often the way this works is your user gives you a query, and then your query goes to something called a router. The router is really just another LLM request. And you basically talk to the AI as if it needs to make a decision about this question. It could look something like this. Is this question hard to answer? And if it is, you go this way. And if it's not, you go this way, right? That might be a really simple router to increase the intelligence to answer a hard question or decrease the intelligence to save cost. But there's actually a lot of reasons that you're going to want these routers. Once it goes through there, now you're probably in another LLM request, and that one is going to further refine whatever's happening. So maybe this is that insurance application we were talking about. And maybe the router is this person wanting to apply for insurance or wanting to make a change to their policy? Okay, and now we've gone into one of those two branches of logic. And now you can have your subsequent prompts be really tailored to that. So in this case, we're in simple router. Now you go to the things that are actually going to make actions. Typically, right now, we're calling these tools in the space. If you guys have heard about tools from OpenAI, these would be the tools that actually produce something. And then that's where you make a deterministic action. Whatever comes out of there, you store something in the database, you send them an email, you do something at that point, and then finally you reply. And it's really good to try to sandwich this whole thing together. I've made the mistake of having the router reply. I've made the mistake of having the functions or the tools reply. I've made the mistake many times in many different ways. Don't do it. Let me save you some pain. Put a reply at the very end so it can post-analyze what just happened and see if anything went wrong or went right. And finally, we send a reply. Now, if you're building an agent, which just means this thing's going to keep working, generally when it hits reply, it's actually talking to itself and explaining what it just did. And then that goes as input to the entire system again, and you run it through again. There's a great article written by the Anthropic team, if you guys are interested in sort of the agentic stuff, where they essentially explain this process. I wish they had written the article a little sooner, because it would have saved me some pain. All right, you definitely want to use tools. Those are those little colored guys. Have you guys ever typed this into an old Mac or a Linux PC? Unfortunately, they don't ship Emacs on Macs anymore, but there is a secret text game on your computer if you have Emacs. And it goes like this. You type it in and it says, dead end, you're at a dead end of a dirt road. The road goes to the east. In the distance, you can see that it'll eventually fork off, blah, 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 blah. This thing is an entire game. You can play for hours on your computer, and you have to just try to guess what the command is here. But what I think this is the best representation of what a tool is. Here, the author has just told us that there is a shovel here. Is there actually a shovel somewhere? No, there is not. They just wrote some text to you and said that there was a shovel. And you can actually type in like pick up shovel, and it'll pick up the shovel. This is exactly what tools are in AI. You basically just tell the AI, hey, there's some tools for you to pick up. One of them is a shovel, the other is a sword. What do you want to do? And then you give it a scenario and it picks up one of the tools, right? That's all it is. It doesn't actually mean that there is a tool or a function anywhere. You're just lying to it and telling it that there is a tool. And then it's up to it to make a decision. It ends up that this is super, super, super helpful. So here's an example. I want to either pour beer or pour wine. This is what a function looks like, or a tool. They used to be called functions. Now they're trying to call them tools. This is what they look like to most of the LLM providers out there. You basically say, here is my tool. This is what you would use it for. And then here are some properties of my tool. Now, these are basically function arguments, and you get to make them up however the heck you want. Whatever you want to say in these function arguments, you tell it. This thing can be as complicated as all hell if you want. But you are determining what type of arguments you're going to put out there for it, and then it fills it in for you.
Does it have to be metric?
It does not.
Okay.
Do whatever you want. Yeah, it's going to fill this out for you, though. And then the really cool thing is, it gives the data to you in JSON. That's really helpful. So this is what comes out the other side. So I could give an LLM those two tools, and then I could have a scenario. Oh, a lady walks into a bar, sits down, she looks really tired. What do you want to do? Pour her a beer, pour her a glass of wine. The LLM will decide for you. Now, I will warn you that you can over-engineer this and confuse our poor.
You're on some kind of weird timer.
Okay. All right, thanks. Cool. You can take this way too far, and if you overcomplicate it, the AI will get progressively worse and worse and worse and worse and worse. My recommendation here would be give it more tools rather than more complicated tools. Try to keep the tools simple. Give it more options to choose from, not too many options. This is by far my favorite way, and I think probably the best way and probably the future way that you should get structured data out of an LLM. You give it tools and you have it pick tools. This is like the cornerstone of building AI. Now, you probably want to use streaming. And what I mean by that is AI mostly works with HTTP requests. The HTTP requests that you get can usually come in one of two forms. One is your traditional full-blown HTTP request. You send something to OpenAI, you wait a while, and then you get the whole thing back. Much better in general to stream the data back. So you will get back something like a UN data array, and it's up to you to determine what's in there as it's coming back. You usually get chunks, like from OpenAI, your chunks are usually coming back in like 4 or 5 characters at a time. So when that JSON is streaming back to you, it's like curly brace, quote, hello, quote. And like you get those tiny little bits as they come in. And it's up to you to determine what to do with that. But in general, this is better. The reason is you can dispatch your next chained event much, much faster if you're trying to read that stream in real time. And it leads to a much better interface. In fact, I would say probably one of the most important things about building an AI app is you don't want to make the user wait very long because everything feels broken. So you want this thing to feel snappy and fast. This is one way to help that. Of course, if it's like ChatGPT, you're all used to that streaming experience because they show you the characters as they come in. And if you have an app where that is the way that you can do it, you can show something progressively, you have to do streaming and there's no other way. Yeah, you can update the UI in real time. Also, there's some other really cool things you can do with streams. So you can T a stream, which basically does what you think. It's like a T shape, right? Now I have 2 different directions. And for any readable stream in JavaScript, you can call .t on it and you get 2 of the exact same stream. And then you can take one of those and call .t on it and do it again. This is great when you're trying to figure out what is inside those streams because it's not obvious when you're just getting a bunch of random bytes that are coming through. So what I often will do is in my code, I will use a T to be able to send the code directly to the front end or wherever it needs to go as it's streaming in. And the other one I'm sending to some kind of a sync to be able to log it so I can see what the heck is happening. Okay, this is the thing I launched today. It's called JSON Reader, and it's at jsonreader.formkit.com. I'll put up a link at the end. And basically, it lets you take that stream of JSON that's coming in and progressively complete it. Because of course, that's one of the problems. If I have a tiny chunk of JSON that's coming in, it's not valid JSON, right? I might be nested 3 arrays deep inside of there. So how can I actually use that until it's finished? Well, this is a tool I wrote for our own purposes that is now out there that lets you basically, it's tracking where you are in that string. So it knows like how many quotes it needs, how many brackets it needs, and everything like that to complete the JSON. And it's an async generator that just yields you new chunks of JSON progressively as they stream in. So you can use tool calls and be progressively updating your AI as you're doing it. I'm sure there's other tools out there like that, but that's the one I did. All right, you might want to use multiplexing. Is anybody familiar with multiplexing from some other domain? No? Okay. Yeah, we got one. So it's really common in like electrical engineering or things like that, where you need to send more than one signal over one wire. And the way that you do that is you basically decide whatever your segmentation is going to be. Okay, I'll send a signal to, device A, and the way I'll do that is I'll say A, and then I'll send a signal, and then when I'm done, I'll say stop, or something like that. And then on the other end, you have something that determines which part of those it belongs to. The reason this is really valuable is if you want to build an AI on the front end where things are really snappy and fast, you either need to create lots of simultaneous streams to the back end, or you need to have one stream that's open that's sending multiple signals at the same time. And there are a number of different ways to do this, but imagine we have one of these like prompt routers and multiple LLM calls are responding to the front end. How do we get all that data back to it? Well, we can take all of these LLM calls and we can pack them into one HTTP stream. And basically you just say like this one belonged to that channel, this one belonged to that channel, and you're writing just little bytes as it goes. And then on the other side, you just unpack it back out. So that lets you just submit one prompt to the back end and then get multiple streams out the front end that are all roughly simultaneous. Quick demo. So this is a tool right here that we wrote, I don't know, a year ago or something. And we wrote a multiplexer for this. So that way it generates forms for you. So that way when you generate a form, it can be progressively requesting form data from many, many LLM calls at the same time. And all of them will be streaming through the single HTTP stream that gets established from the beginning, all back out in the same place. So I could say patient intake form. All right, and the thing to see here is that you can see there's multiple things happening at the exact same time, not just one, but there is actually only one HTTP stream there. And it was all just packed over the same one. So I think right there, we probably made like 15 requests to OpenAI, and they all came back at the same time. And by doing that, we were able to produce this form really freaking fast. All right. So that is multiplexing. There's not enough talk going on about this stuff. So I think y'all should look into it. All right, now how about this? Stupid models, right? Here's what I would say. Start with the dumbest model you can. Try to build your application with the worst case scenario, and then add more intelligence only when it's absolutely necessary. These are the two cheap models right now, unless you want to go with like one of the llama ones. But honestly, they're not very good. I know everybody wants them to be good because they're open source. They're just not very good. Not when it comes to doing like actual production grade app stuff. So I would recommend one of these two models right now. They're both pretty good at tool calling. Flash 2.0 is supposed to be like way smarter than Mini. And I can't prove that yet or not because I haven't used it. So I don't know. But we start everything with 4.0 Mini, which is a genuinely stupid model. It's not intelligent. But that's where we start. And then we try to constrain the options and try to get it to do the right thing as much as possible. And if it cannot, we will upgrade. But remember, that's a 16x cost increase. And there's nothing in between really right now. There's O3 Mini, which is sort of in between, but its function calling capabilities are much reduced compared to 4.0 or 4.0 Mini. All right, you are definitely going to need to build up your intuition for these prompts. Just like we were saying before, we are lacking as developers in intuition for how these LLMs work. and we need to do that. The first thing to know is that the LLM is completely stateless. This should be very familiar to us. It's actually a little bit of a breath of fresh air, to be honest. I didn't realize this when I first started working on it. I thought that like somehow state was staying over there at OpenAI. No, there's no state, right? Even in ChatGPT, when you are having a conversation with ChatGPT, each successive message, the entire stack gets sent on every single request. So your entire conversation, every single time. There is no actual memory, no actual success of anything. Even like the core memory features and stuff like that, those are getting injected into your prompts. It is really just like hitting an endpoint with some data and getting something back out the other side. What's cool about this is it means you can manipulate this like crazy. You can inject whatever you want into there. You can fake things. You can pretend that a conversation happened that didn't happen. You can do all kinds of really, really interesting little tweaks and engineering workarounds in order to get these things to work a little bit better. So remember that it's stateless. Also, what I found is the most helpful thing to do is to try to constrain your LLM down to a small number of decisions. So like you don't want, for insurance advisor, you don't want that LLM to have all of the options of your application. You need to figure out a way to route it to a small set of options. And then that within that small set of options, you want to say almost nothing. Because are you guys familiar with the needle in the haystack eval that people do? They'll basically take a huge book and they'll give it to the model. And then somewhere in the middle, they'll like put a cookie dough recipe or something really silly. And they try to make it really small. And then they ask it like, hey, how's that book? Do you like it? Pretty good book. And the LLM is like, what they're looking for is for it to be like, yeah, it's a pretty good book. There's a weird thing. In the middle of Harry Potter, they talk about a cookie dough recipe. Isn't that weird? And that's what they're looking for. So these models are hyper trained to pay attention to really tiny details. So when you give it guidance in your system prompt, it like thinks that the world is going to end if it doesn't satisfy that. So when you give it options of what to do, it sort of starts to like get overweighted in one direction or another. It's incredibly hard not to bias the LLM to go in one direction or the other. So what I have found is the most helpful is don't give it a lot of options. Try to use a router or something to get it to a place where there's not a lot of options. And then don't say too much. Just kind of shut up and say, what should I do here? Just my advice. All right. Also, this is a small little detail, but it has a really big impact. When you're defining your tools, like when we defined that tool, pour beer or something, we had a description in there that said when you would want to use that tool. That goes to the LLM, and the LLM does read that. That's part of how it knows. But you really will do much better if you also describe the tool in your system prompt. It needs both and. That piece of advice might not be true in 6 months, but it's true as hell right now. All right, another big one is put all your dynamic data at the end of your LLM request. This is super important, actually. So remember that it's stateless. So your entire conversation builds up over time. Every single time you're having a communication with the LLM, you're sending that entire conversation, and you can think of it as effectively static. Now, one of the questions is, well, where do I put this user's context, right? Somewhere in there, I probably want to inject something about my user, like my user's subscription status, or maybe their preferences or things like that. You want the AI to know that. Well, if you stick it at the top, you get a cache miss. And the way that OpenAI and to some degree Anthropic, depending on the model, the way that they work is they break down the entire string at 1,024 bytes, and every 1,024 bytes gets cached. And the second time you request it, you pay half price. So what you want to do is structure your stuff so that way you are constantly sending exactly the same data, and at the very end, you do some sort of injection to put all of the dynamic data at the very end. Also, I made this mistake for like a year. The way that these things get structured, it's an array of little objects where it has like role assistant content, role user content, just this tiny little long array. Somewhere in there, you've got to put all of that context that we just talked about, like the user account information or things like that. So what most people do, and if you go read blogs, what a lot of people do is they put it in the last user message. They have a big block of context. And then somewhere in there, they say, and the user is now saying this, right? And it's part of that. That does not work very well. The LLM, like at first it seems like it's working well, but the LLM starts to get confused and starts to sometimes think that, oh, that context block is coming from the user. And thus, like, they just told me about their account information. How strange. Let me remember all that information all over again. It doesn't work that great. So what I do now is I create a fake tool call, which you are allowed to put in that stream, and it ends up at the very end. And that's where it all goes. That won't make sense to you until you're building, but it will make sense at that point. Okay, so we built that form builder, and the form builder was really interesting. But it turns out developers are really scared of AI. And we decided we wanted to try building like just completely crazy, totally different thing. And developers all hate working out. So we said, what if we just built a fitness coach? All right, so we actually haven't told anybody about this, and it's not done yet. But I want to show you the process that we're using, and specifically the dev tools that we've had to develop for ourselves. So you guys all get an idea of sort of what goes into the engineering of one of these things. And in the process, you might think the idea is cool, and there's a place you can go to. This bod.coach is actually a URL, believe it or not. And you can go in there and sign up. And at some point, we're going to send out like an early batch of beta testers, and you could be on that list. So let me show you right now, just running locally, bod coach. All right, so here, obviously it's intended for mobile use a little bit, but basically you come in here on your phone and then you get to pick a trainer. So these are all different personalities. I'm gonna go ahead and pick Natasha here. And the idea is there's no app because apps are sort of maybe an older form of interaction. And in our world that we live in, the main app on your phone is your text, right? That's how you communicate with everybody, is where you're spending a lot of your time. So this literally just downloads a V card to your phone, a contact card, and then she starts to text you. All right, she's gonna collect some information. I'm a male. That will make me old to some of you and young to some of you. All right. Now, I don't actually want her to text me, but I'm gonna go to my dev tools here. And these are the dev tools that we have come up with to solve a lot of the problems we were talking about. So here I can see my thread. And this is the text message that I would have received on my phone if I was actually doing it. Oh, look at this. I'm gonna sit down. I've never sat down in a talk before. Okay. And so what I want you to look at here is on this side over here, you can actually see a live WebSocket connected view into the LLM, into the router, and into everything that's happening. So I'm going to go ahead and respond here. I'll say, my name is Justin. And I send that. And now you can see that this thing got kicked off. This was a purely deterministic message. We received that via a webhook, and then we just immediately responded. We didn't actually care. I could have said anything there. It didn't matter. So and the reason is we need to validate their phone number first. Okay, we're gonna do that. All right. Now I'm really in. This here sends you a V card via MMS. This is not hooked up to MMS, so we didn't receive the V card, but you can kind of see what's actually happening here. All right, what's my height and weight? I'm 6'1", about 190. All right, now look over here. So we just hit something called the onboarding router. And the onboarding router then redirected me to 2 more LLM requests. So it came in, and if we look down here, we can actually see the prompt context. So that's all that injection information that we were talking about. And here I can see our system prompt. So this is what it actually looks like. You are a personal fitness trainer who works for a company called Bod Coach. Your name is Trainer Natasha. You're energetic and blah, 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 right? We are telling the LLM, just like you would, what goes into this. Then down here, we have our instructions. Now remember, we hit the onboarding router. That's because these things are stupid. And we need to constrain the options that are available to it as much as possible. So we are deterministically reading the database and saying, this user doesn't have an account yet. They're not finished going through this, so we can put them in the onboarding router. And we deterministically place them there. All right, so you kind of get an idea of what's happening here. We are describing the actions that they can actually take. Here's some validation, right? And it's like, it's literally programming in human English. It's very weird. Clarify any details that are inaccurate, like they're 10 feet tall or 130 years old or 500 pounds, right? We literally write all of these things out and try as best as possible to describe it. So this is the system context. Now it's quite a bit, right? That's why it's always placed at the top, because that's going to be a cache hit on basically 100% of users. So we pay 50% for it. Also, you can see that we are using ChatGPT 4.0 mini, which is dirt cheap. So the total cost for that interaction was whatever that is. I can't even tell. Not a lot, right? It was pretty cheap. Okay. So it returned this. It said, okay, the function here should be set user profile details. It was able to determine from me saying that I'm 6'1" and 190 pounds that it needs to store some information on me. And it decided to use set user profile details. So it rewrote the prompt to the next LLM, right? And that LLM received less information. It didn't even receive the conversation history. We didn't even send that. All we sent it was, hey, Justin's 6'1" and 190 pounds. So that was this guy. Now this one received its own system information, its own system context, its own instructions, and it also included, in the context here, everything that we already know about the user. And so its job is to basically say, should I actually store that information or not? Because you get a lot of false positives, right? These things they're kind of, they make mistakes. So we're double checking. Okay, you said I should store that at 6'1" and 190 pounds, but did he already tell me that information, or is it wrong in some other way? And in this case, it decided, oh, I should actually store that. So then it made two function calls. One to say the height is 6'1", the other one to say the weight is 190. So we've now taken this very fuzzy input and we've reduced it through a series of steps down to something that's extremely deterministic. That gets stored in a database, and we can actually see that right here. So we actually know that information from the user. Okay, so yeah, let's say I want to lose weight. I want to get to 180. All right, so here you can see the same thing happened. We're setting user profile details. And then at the very end of that, this guy, this responder, basically retrospectively looked back on how things went and made a determination about how it should respond. In order to do that, we send it the history. So here is the history. This is what actually gets sent to the LLM. It looks like this. It's an array with these little role and content, right? So here you can see there's a role. This is all that system information. Here is now our content from the assistant. That was our first message. Here's our second message, so on and so forth. Now, down here, we get into some weird places where now we inject back into the history the fact that the LLM made those function calls. We are responsible for crafting that information. You as the engineer are responsible for doing that because you're the one that gives it that information. So it's up to you to determine what you actually tell it happened. So we store the fact that those function calls were made. And the main reason to do that is now the LLM has its own context when it's making the next decision about what to do or what not to do. So it's probably not going to make the mistake of saving that information again, because it can see in the history that it did that. Now, if we keep going down through here, you'll see our conversation is already continuing. And then somewhere down here, we end up with this. Here's a tool call. Now, at this point, I'm just straight lying to the LLM. The LLM thinks that it asked to know everything about the user. It thinks that it decided I need more information on the context of this user. And so the assistant, the LLM, asked for a tool called load context. That never happened. I'm just telling it that it did. And then the response to that is this tool spewing out the context about the user. So this is where the account information would be in there and all that other information would come. It gets injected in there as if the AI asked for it and received the response. And you'll notice this happens directly above where this last action actually took place. So the last thing on here is whatever action just took place. Set of memory and store onboarding details. Those are those two functions that just fired as a response to this. And by doing that, now the last LLM can say, hey, look back on the most recent things that we did in the tool call and make sure it works. And that's how you get robust error handling. Because there was a chance that one of those things errored out. And then instead of saying down here that it was successful, we would say something like error. You really put whatever you want there. You just lie to it. And then the responder can look at that and be like, oh man, I know you just told me that you want to get down to 180, but for some reason I wasn't able to remember that. Could you tell me again? Something like that. So you can have this kind of robust error handling. I could go on this for quite a while, but my time is up. And I wanted you guys to be able to see how these things actually get stitched together. So that is basically the end. There's nobody coming in after this, so I have time for questions if anybody has any questions, but I am basically done. Yeah.
So when you're constraining the LLM to a particular schema, is OpenAI or any of the models, are they guaranteeing that it will fit to that?
Great question. No. OpenAI does. So OpenAI, if you are using one of a certain set of models, you can tell it that you demand structured data. If you do that, all of your properties become required. So that means you need to, if it's like an optional property, because of course there's optional ones, you need to provide it and like essentially an array. You're either going to provide me null or you're going to provide me a value. So it is a little bit cumbersome to work with, but you can constrain it. OpenAI is the only one making this guarantee right now. Yeah.
Was that all like custom rolled, or do you guys make use of any like frameworks like LangChain?
All custom rolled. We did make use of LangChain and we threw it out the window. Didn't like it. Yeah. It's not that, like, I'm sure that for some people they find plenty of use for it. These tools probably took 2 days to write. Obviously using AI, right? So they really weren't that hard to write. It's mostly the infrastructure that takes a lot of time. So the like that JSON reader, that thing was a pain in the ass, but now you have it too. And the multiplexer, that was a pain in the ass. So like there are pieces of it that were really hard. The dev tools actually weren't that hard to build, but what we found is if you don't have those dev tools, you are in complete darkness. You're not even sure what you actually sent to the LLM. And often the reason that the LLM is giving you a hard time is because you left something in one of your prompts and you forgot about it. And now you've changed it and it's like hooked onto that like needle in a haystack. And damn it, it's going to do whatever that one thing is. And you have to just be like, okay, let me read the whole thing once it's assembled. Because of course, in our case, like our prompts are in like lots of different little files, you know, and we're inserting them and stuff like that. So I should mention though, OpenAI 2 days ago released something called Agent API and Responses API. And they basically built a similar tool set to what I just showed you. I can't tell you if it's good or not yet because I haven't tried it. I'm a little concerned about like the vendor lock-in part of that, you know. That's another thing we didn't really talk about, but as you're working your way through the model or the router, because it's stateless, you can bounce that to whatever provider you want to any model. So there's times where we come in on the front end and we go to OpenAI, then we go to Grok, G-R-O-Q, Grok. And then we might come back to OpenAI, or we might go to a really high level model. Like when we're actually generating a workout for somebody, we go all the way up to O3. So it just depends on which part we're in. Yeah, that's really important. You need to be able to change models. Yeah.
If you went through and gave all the same inputs again, would it give you the same answer?
No, it would not. You have some control over that. You can set a temperature, and that's basically a variability on like how stochastic it's going to be on the backside. It's still probabilistic no matter what. So and that is one of the scary things is this thing will cause problems and it will have errors. Even with OpenAI's guarantee, we have gotten back bad JSON. Occasionally we've gotten back Russian for no reason. So yeah.
That was my question. When you put a prompt in, does it matter? I'm really new to AI. Can it be bilingual?
Yeah.
Prompt in French.
Not only that, it's like, I could just say here, like, hey, from now on, talk to me in French.
Yeah, but what about when you?
So yeah, if it can do it, then I can do it, right? Yeah, so now I'm in French. And so, yes, I could tell the same.
Some languages don't translate.
Some languages don't translate well. And there are some in particular that don't use the same forms that we do. One of the really fascinating things about AI is there's less intelligence there than we think there is. And I don't mean that as in like they're stupid, like I was joking about before. They are actually very, very good at looking intelligent without actually having any intelligence. And the way that they do that is that they are essentially recreating the form of language, right? So like if any of you took Latin in high school or something like that, and you learned that languages are structured logically in a certain way, they have figured out how to recreate form. They don't know why they're recreating the form. So they're very, very, very good at doing that. They can recreate form incredibly well. But when you ask it to make a decision or a value judgment or something like that, they're very bad at it. And that's why all of these reasoning models basically are layering multiple layers of LLM requests where they're trying to use the limited intelligence to come to some form of actual nugget of truth or intelligence at the end of the day. So where that comes out with language is that it's not very hard for these things to recreate languages that are roughly in the same form, but some languages that are very far from our form, they don't do as well with. But like pretty much any Western European language, Russian, things like that, it'll do pretty well. And it's also quite good at Chinese just because of the population. And that varied by model too. Some models are bad at them all. Yeah.
You gave the tip of having a bunch of simple tools rather than having a small number of complex dynamic tools. Have you all found like the sweet spot of a max number of simple tools to give to the LLM? Do you find the need to have like tool selection, error correction at some point?
You do need to have tool selection, error correction. Absolutely. Which is sort of what we saw there on set user profile details. That was essentially an error checking step as well. Because it will call them sporadically. But in general, I would say you want to keep it at like no more than 8.
Okay.
Definitely no more than 8. And they need to be relatively simple. We made a really critical error building this the first time where we said, okay, so there's the other thing to consider is if you're going to allow multiple tool calls at the same time. In OpenAI's case, they call that parallel tool calls. Parallel tool calls are very cool because you can ask the AI to do more than one thing at the same time. Great. The problem is that they don't support the structured output. They will not guarantee that your JSON is going to be correct when it comes out if you use that. So we said, aha, we're smarter than you. What we'll do is we'll make a function that asks for the functions as arguments, right? We'll just wrap that whole thing. And then we'll even have the response as part of that. So the response, so like one of the arguments will be like, what do you want to say back to the user? This is a catastrophic mistake. We have to refactor the whole thing. And the reason was, what we, like, this is part of the intuition that I was talking about. Part of the intuition that we learned that we didn't know, and that's not part of the published details, it's just something you have to learn, is you can almost think of these things as having 2 brains. One is syntax, and the other is form, and linguistic form. All of them are very good at linguistic form, and some of them are okay at this syntax thing. Claude is the best. When they are in syntax mode, they can't write very good English. They don't sound natural. They sound robotic and bad. And so they actually come out in two different places on the API response, that makes it easy for all of us to understand that I'm talking to a different part of its brain. So you need to account for that. So that's one of the reasons that this responder is doing its own thing, is because it's not doing any function call. It's talking to it just like ChatGPT would, so that way we can glean that part of the brain. That makes any sense. Yeah,
You're saying like function call and tool call, is that the same thing?
it's the same thing. Yeah, sorry.
Okay.
Yeah. Yes.
Can you talk a little bit about your app architecture here, the sequencing of events and calls and triggering and how you're storing one to the next?
Yeah.
Or is that too much? Or
It is very complicated. But the crux of it is that what we do behind the scenes is we create a multiplex stream that we don't send anywhere. Then we make our initial request and we start streaming the response back into that stream. Then on the backside, we're consuming it with a sync. And as we find enough information to fire off the next call, we fire it basically in a loop so that way its value goes into the same stream. And then by doing that, we end up, and then as it's telling it to do things, we start stacking them on a queue. And then as that queue is getting consumed, they're all pushing it onto the same stream. And one of the reasons for doing that is we can have a single place that we can introspect to read and write to. Another reason is if we ever decide to pipe this from here to, let's say, a front end, we can do that immediately. We can pipe all of this chaining directly to a front end and get a front end update in real time. And it gives us one of the really hard, like weirdly hard things to do in AI is know when something starts and when it stops. The end point is a big problem. So this gives us a way to have the end point for the entire chain. So that's like a high level overview of how it works. Yeah. Yes.
Given that it's structured, are you using an LLM to determine if it's an error, like if there's an error? Or is there still things that you kind of have?
That's a good question. That's a good question. You can see this one right here, this eval router that errors out. That is doing what you're saying. This is, and it's just not hooked up right now, which is why it's erroring. That is doing introspection on the chain of communication and saying, is this thing going well? or am I being dumb, right? Do I need to somehow jump in here? So that's the only part where the LLM is responsible for evaluating the chain. If there are any deterministic errors, like JavaScript throws an error, there's a foreign key constraint that fails or something like that, then what we do is we inject that into the conversation like a tool call. And by the time it hits the responder will fire if nothing else has replied. So by the time it fires, it's able to look back and say, oh, there was a problem in here. And thus I must respond in a way that describes the problem. So it's a little bit of eval on that part, but not a lot. Yeah.
This is more of a question about your example, but it doesn't seem like the cost on the one side matches it in the text window. Is there some other thing adding to the cost?
The estimated cost of the text thread is just estimated by us.
Yeah, this is ours. The real cost for our product is these SMS messages.
Oh,
yeah,
that's your margin.
Yeah,
okay.
Yeah, that's expensive. These are relatively cheap. Maybe I can find one here. Let's see. And you push all my workouts to next week. I'm out of town, whatever. Well, another great thing is you can have typos and it doesn't care, right? It's very good. Let's see if this does it. Yeah, just to confirm, yes. Okay. So this, in theory, should reschedule all my workouts, which is actually very hard for an LLM to do because it's time-based. So it sucks at being like Monday is after, Sunday. So what we do here is, we hit the primary router, which is cheap, and then we hit this reschedule workouts. And you can see here, this goes up to GPT 4.0. And now that one, just that one costs us almost 3 cents. So that's how these things kind of bounce around. Yeah, a lot of stuff happening. This is much further down in the app when there's a lot of other stuff to happen. Yes.
I have 2 questions. My first question is, considering high cost just for that one request, like how would you, I guess, safeguard against people potentially exploiting it with or without you knowing that they're like incurring all those charges?
That's a big question. And it's actually not even just that. Because these things are cyclic in nature, a bug in your code can cause it to infinitely request the LLM. So in our case, we have safeguards in there where we are counting the sequence costs as it's going. We haven't written any for total cost on here yet, but like on Kickstart, that other one we showed that generated forms, in that one, we actually sum the value of the user over time. And even when you purchase it, we put a value that's like far past what you paid for it. So we will eat it, but at least we're not going to go bankrupt. And we block it at some point. Yeah. Yeah.
Cool. And then the second question is, if you could give yourself some advice when you first started this, I guess, adventure into AI, what advice would you give you back then?
I think that like tension that you feel as a developer to not recreate the wheel, but like you kind of want to recreate the wheel. It's like I kind of want to like write my own thing, but I know I shouldn't, so like I'm gonna go look for a tool. Just recreate the wheel for right now. It's probably better to just do that. You're gonna understand it better. You'll know the stack better. The tools, even the ones that are out there by the big companies like LangChain and stuff like that, they're not good enough yet that your tool that you write with AI and much more intimately isn't going to probably be better than it. So I think that's where I would start. Yeah. Other than JSON reader, you should use that. Yeah.
Are the open source models still too stupid for the use cases?
That's a good question. In my experience, they're not very good yet at the function calling or the tool calling. They're not terrible at it. The other problem is that everybody's lying to you about what model you're actually interacting with. So on these, they're not actually lying, but it's deceptive. Like, okay, let me give you an example. DeepSeek comes out, right? And everybody's like, DeepSeek's amazing. You can run DeepSeek on your Mac. You're not running DeepSeek R1 on your Mac. You like physically can't do it, right? The best you can do, if you have a top of the line MacBook Pro, you might be able to run the 30B model, which is 30 billion parameters. It's been quantized down to that size. At 30 billion parameters, you have lost a tremendous amount of intelligence, particularly on those edge cases, right? On like the least likely outcomes, which make it you be able to fall out of the happy path very easily. And so what I found is that a lot of the tools that are out there, they sniff really well, especially when you're talking with it in its preferred form, which is linguistic form. But as soon as you ask it for intelligence, it kind of falls short. So, the one exception that we have used is Grok. I don't know if you guys are familiar with these guys. These guys produce hardware. They call it an LPU, a language processing unit. And I don't know, that part might be snake oil. I don't even know. What I do know is that if you get an invite to it, it is freaking fast. So here's Llama 70B. But like what we will do is if we don't need a lot of intelligence, we'll go down to Llama 8B. And we do this particularly on places where we want something that the user didn't even think was AI, right? Like we made some sort of classification decision. We've used it to write logic statements in a reduced language. So like a really simple language where you want to be able to write like an if statement or something like that behind the scenes, and it can happen really fast. So like write a story about a guy giving a talk at JS. What is this? JS RVA JS. Submit. Real fast. Yeah. So you can see here, this is at 750 tokens per second. So OpenAI, like the 4.0 and Mini are around 69 to 80. So this is way faster. And this is not even the fastest. They have some that go up to 3,000. Yeah, so you can get like almost instantaneous responses, but they're not that smart, so you have to be.
Thing that wouldn't stand for the California.
React virtual annual conference. Yep.
You write code that fast?
Yeah, it does actually. There's a bunch of demos where you can basically like click on code and this thing will generate iterations of it for you like instantly. It's very cool. Yeah, and so they have DeepSeek 70B. And write me a story about a guy going to a bar after a conference talk. See what it says.
In less than 5 minutes.
All right, so you can see it's like that's way faster than you're ever going to get out of DeepSeek. And it is 70B. So you're getting 275. Now that's going to be pretty smart, but the raw value of R1 or the parameter count of R1 is 671, I think, is the actual, like if you actually use DeepSeek, it's 671 billion token or billion parameters, and this is 70. So it's got a lot of it, but it's not going to be as smart. DeepSeek, in my opinion, is just vaporware at this point because you can't actually get it hosted at 671 billion parameters anywhere. It's like basically doesn't exist. You have to rent your own H100, which is expensive. I looked into it. Yeah.
Speak to a little bit like how you think about decide when you need to show out for a more sophisticated model and kind of problems are perfectly fine with it.
So at this point, it's like started to come to, for me, the point where I have at least some intuition. And most of that comes around the kind of text responses that I'm going to get. And most of the models do a pretty good job of responding to language, most of them. But if you have to do any sort of mathematics, any sort of time, any sort of selection that requires expertise. So in like the bod coach example, you are selecting things based on that user's profile, right? Like if I tell it my leg is broken and it gives me a bunch of squats to do for a workout, that's bad. So that's where you just like have to pay for it. You know, there's no alternative. Yeah. Yeah, that is the last slide. So if you want to join the early access list there's JSON Reader, which was launched earlier today. And there's Beer, which I'm going to go have now.